Okay, in this video we're going to go over the similar right triangles, and we're going to be using geometric means. Okay, so geometric means is our focus. So you need to find y, x, and z. Okay, each of these variables operate as geometric means based on their location. So we have a leg, we have an altitude, and we have another leg. So these three components of a right triangle, when you drop an altitude inside, are functioning as geometric means. It's a type of average. So with that knowledge, we can solve for each of these variables. So the first one we're going to work from left to right. So the geometric means are part of ratios. The geometric mean always goes low, high. So geometric means always repeat. Okay, the leg y is the geometric mean between the piece of the original hypotenuse closest to it and the entire hypotenuse. And I'm going to change these numbers, so let me back up for a second. Since making this copy, I changed these numbers, so your numbers say this instead. So let me just change this so that we're all on the same page. This is 5, and this is 8 with your numbers. Okay, so given that, let me go back to the purple, and we're going to find y. So this leg is the geometric mean. That's why I'm in the geometric mean position between the piece of the hypotenuse closest to it and the entire hypotenuse. So when you add those together, 8 and 5 should be 13. So I'm going to put 13 here. Okay, so now do your cross product. So y times y is y squared, and that equals 5 times 13. So I don't want y squared, I want y. So I'm taking the square root of each side. Look what I'm finding for y. Both 5 and 13 are prime numbers, so I cannot reduce those any further. There are no other components of 5 that I can break it down into. There are no other components of 13. So go ahead and multiply those two numbers together, and you get 65. So therefore, y equals radical 65, and that is as simple as I can write my y. I cannot simplify that radical any further. Okay, let's try to work on x now. So let me do a little bit of erasing just to clean things up. I'm going to erase the purple marks that pertained to the leg that we defined as y. And now we're going to change our color. So let me go to a green, and I'm going to say I want to solve for x. So x is an altitude, and that altitude is the geometric mean. Okay, so I said the altitude comes straight down and forms a right angle. It's the geometric mean between the 5 and the 8. So put 5 and 8 here. Okay, so do your multiplication. X squared equals 5 times 8. Okay, so take the square root of both sides. X equals radical 5 times 8. Now, can't I write 8 as 2 times 2 times 2? No, we're just going to clean up that last one. Times 2 times 2. Isn't that true? 2 times 2 is 4. 4 times 2 is 8. Okay, simplifying the radical, x equals, here's a pair of 2's. They come out as a single 2. What's left inside is a 10. So x equals 2 root 10. Okay? Up in the corner, we're going to do the other leg. The other leg is z, and I will use a brownish color for that. So z is also going to function as a geometric mean. It is a leg of the original right triangle. So as the geometric mean, the z is going to go low, high. Okay, the z acts as the geometric mean between the side of the hypotenuse closest to it and the sum. 8 and 5 is 13, so that's going to be 13. Okay, so now what do I know? I know doing my cross products, z squared equals 8 times 13. Taking the square root of both sides, z equals 8, which I already know is 2 times 2 times 2 times the 13. And let me just erase that so I can get it to be a little bit cleaner. So taking the square root of both sides, z equals 2 times 2 times 2. Okay, that is 8 times 13, which is prime. Here is a pair of 2's right here. Pull that pair out as a single 2. Radical, 2 and 13 are left inside. Multiply them, and you get 26. So z equals 2 root 26. And we have all three geometric means solved. Okay, so you really want to know how to do this. The legs and the altitude act as geometric means. They always repeat 2 times. They happen to be variables here. They could have just as easily have been numbers, and you have many examples of this from our review sheets. Okay, so this is the end of the video for problem number 34.